Today's question is x raised to the power of 4 plus square root of x raised to the power of 2 plus 7, that is equal to 7. We need to find x value here. Let's see how to solve. Here we have a square root. If we have a square root, always we are trying to get rid of the square root, isn't it? To get rid of square root, we always do square on both sides. But here we can't do square. If you do square here, you cannot do individual term. You have to do the whole term. So you have to do here. Then the left hand side turns into the first term. It is going to be x raised to the power of 4 whole square, isn't it? So it is in the form of a raised to the power of m times n, and it's going to be x raised to the power of 4 times 2, which is 8. And it is more difficult to solve for the x. That's why you should not do square here. Instead of doing square, let us consider square root of x square plus 7 as some other variable a. Then our original equation turns into x raised to the power of 4 plus the second term we consider as a. Just write a, that is equal to 7. From here, if you do square on both sides, then you will get the square and square root gets cancelled, so we left only x raised to the power of 2 plus 7, that is equal to a raised to the power of 2. X raised to the power of 2 is a raised to the power of 2 minus 7. So if you consider the second term as a constant, you need to convert the first term also in terms of a, isn't it? So that's why we need to do square here. Then the left hand turns into x raised to the power of 4, that is equal to a raised to the power of 2 minus 7 whole square. It is in the form of a minus b whole square. The formula is a square plus b square minus 2ab. So let's use that formula. It turns into a square, that is a power 2 whole power 2. So which will give a power 4 plus b power 4. b power 4 is 7 power 2, which is 49, minus 2 times our a is a power 2 and b is 7. So 2 times 7 is 14. So the last term is 14 a power 2. So instead of x raised to the power of 4, I am going to write this term. That is a raised to the power of 4. First I will write a raised to the power of 2 term minus 14 a raised to the power of 2. Then I write the constant term 49. So we are done with x raised to the power of 4. Now we have to write a plus a. This equal to 7. If you send it to left hand side, it becomes minus 7, that is equal to 0. 49 minus 7, which gives plus 42. So just write only 42 here. We need to find roots of this equation. Here we have a power 4. That means we are going to get 4 roots here. Let's see how to find out. To find the first root, I am going to use hit and trial method. So first I am going to substitute a as 2. So if you substitute a as 2, so then 2 power 4 is 16 minus 14 times a raised to the power of 2, that is 2 raised to the power of 2, the value is 4. So 14 times 4, which gives 56. Just write 56 plus a value is 2 plus 42, that is equal to 0. 16 plus 2, which gives 18. 18 plus 42, which gives only 60. 60 minus 56, which is not going to be equal. A equal to 2 is not a root. Let's consider a as 3. Then a raised to the power of 4, that is 3 raised to the power of 4, the value is 81. So let's write only 81 here. Then minus 14 times a raised to the power of 4, that is 3 raised to the power of 2, which is 9. So 14 times 9 is 126. So let's write here 126 plus our a is 3. So let's write only 3 plus 42, that is equal to 0. So 42 plus 3, which gives 45. So 45 plus 81, which gives 126. 126 minus 126, which is equal to 0. So that means a equal to 3 is our first root. So if we write as a factor, that is a minus 3 is a factor of this equation. So now using this factor and long division method, I am going to find the another factor of this equation. Here we have a raised to the power of 4 and here we have a. So that's why we need to do with a raised to the power of 3. So a times a raised to the power of 3, which gives a raised to the power of 4, minus a 3 times a raised to the power of 3. So if you subtract here we have plus, that's why it become minus, and here we have minus, it become plus. These two gets cancelled. So we left only 3a power 3, and here we have a power 2 term. So let's take minus 14 a power 2. Now here we have a power 3 and here we have a. So that's why we have to do with a power 2. Let's do with plus 3a power 2. So a times 3a power 2, which gives 3a power 3, minus 3 times 3a power 2, which gives minus 9a power 2, After subtracting, then you will get minus 14a power 2 plus 9a power 2, which gives minus 5a power 2. And what we have a, so let's take it down, a. Now we have minus 5a power 2. That's why we have to do with minus 5a. A times minus 5a, which gives minus 5a power 2. Minus term minus plus, just write only plus. 3 times 5a, which gives 15a. So these two gets cancelled. So we left only minus 14a and remaining constant plus 42. Now we have to do with minus 14. To do with minus 14, then a times minus 14, which gives minus 14a. Minus term minus plus. So then 3 times 14, which gives 42. Then do subtraction, then you will get 0. So another factor is a raised to power of 3 plus 3a raised to power of 2 minus 5a minus 14. These two factors we can write this as a minus 3 equal to 0. From here we can say that a equal to 3. This is our first root. And here we have a cube plus 3a power 2 minus 5a minus 14 equals 0. Here you need to get 3 roots. Observe here we have 14. This 14 we can write it as 2 times 7. So 2 times 7 is 14, isn't it? And also see, observe here we have minus 5a. Minus 5a also we can write it as minus 7a plus 2a, which gives 5a, isn't it? So here we have a 2 and here we have a 2. So I'm trying to convert all in terms of 2. That's why this 3a power 2 also try to convert in terms of a 2. That is 2a power 2 plus a power 2. Here also we have a 2. From these two terms, if you take it a power 2 as common, so what you left? We left only a plus 2, isn't it? So now a power 2 plus 2a. From these two terms, if you take it a as common, so you left a plus 2, isn't it? Here a plus 2 and here a plus 2. See, now what we have? We have minus 7a and this is 2 times 7. That is minus 7a and minus 14 you have. So here also, if you take it minus 7 as common, so you left only a plus 2. So now here a plus 2, a plus 2, a plus 2 are common. So that's why take it a plus 2 as common. So you left only a power 2 plus a minus 7, that is equal to 0. From here we can say that a plus 2 equal to 0. So that is a equal to minus 2. This is our second solution. From a power 2 plus a minus, from here we are going to find another two roots. That is a equal to, we have to use the quadratic equation formula, that is minus b plus or minus square root of b square minus 4ac by 2a. Use that formula here. So that is minus b is minus 1 plus or minus square root of b square, that is 1 square, which is 1, minus 4 times our a is 1 and c is minus 7. So minus 4 times minus 7, which gives plus 28. 1 plus 28, which gives 29. And square root of 29, the value is 5.385 divided by 2. This is the third and fourth roots. So our first root is 3 and second root is minus 2 and third root is minus 1 plus 5.385 divided by 2, and the fourth root is minus 1 minus 5.385 divided by 2. This is our fourth root. The third root plus 5.385 minus 1, which gives 4.385. If you do divided by 2, then you will get 2.1925. So we can simply write this as 2.2. Observe the fourth root. Minus 1 minus 5.385, which gives minus 6.385. If you do divided by 2, then you will get minus 3.19. So this we can write as 3.2 only. So the fourth root is minus 3.2. But is these roots are satisfied of a given equation or not? Let's go and check. We consider square root of x raised to the power of 2 plus 7, that is equal to a. So let's take the first root, which is 3. So let's take a as 3. So if you do square here, then you will get x raised to the power of, here square and square root gets cancelled. So x raised to the power of 2 plus 7, that is equal to 9. So then x power 2, that is equal to 9 minus 7, which is 2. So then x equal to plus or minus root 2. Now this x value substitute in our original equation and it's satisfied or not, let's check. This is our original equation. So let's take x as plus 2. Then x power 2 is root 2 whole square, which is 2 only. So the x square, the value is 2. This x raised to the power of 4, we can write it as x raised to the power of 2 whole raised to the power of 2. This x raised to the power of 2, the value is 2. So instead of x raised to the power of 2, I'm going to take 2. So 2 power 2, the value is 4. So let's write only 4 here. Plus square root of x raised to the power of 2, the value is 2, plus 7. 2 plus 7, which gives 9. So square root of 9, the value is 3. So 4 plus 3, that is equal to 7. So left hand side, that is equal to right hand side. That means x equal to plus root 2 is satisfied our original equation. Now let's check for the negative case. So now let's take x as minus root 2. So if you take x as minus root 2, if you do square here, then you will get plus 2. If x power 2 is 2, then x power 4 is 2 power 2, which is 4, plus here also x power 2, the value is 2, then 2 plus 7, which gives 9. So square root of 9, the value is 3. So 4 plus 3, that is 7. So x equal to minus root 2 also satisfied our original equation. Let's take a as minus 2. So we consider x raised to the power of 2 plus 7 as a. So let's take minus 2. To get rid of this square root, we are doing square here. So then x raised to the power of 2 plus 7, that is equal to minus 2 whole square, that is 4 only. Then x raised to the power of 2, that is equal to 4 minus 7, so which is minus 3. But x power 2 cannot be negative. So that's why this root we cannot take it. Because square value always should be positive. It cannot be negative. That's why a is minus 2 is not a valid solution. So now let's take another root, which is 2.2. Here we have to, instead of a, we have to take 2.2. Let's take 2.2. So now do square on both sides to get rid of this square root. Then here square and square root gets cancelled. So we left only x raised to the power of 2 plus 7, that is equal to 2.2 whole square. So 2.2 whole square. So using our square trick, we are going to find the 0.2 whole power 2 value. So first you have to do square the tens digit. 2 square is 4, you write it as a double digit. Then again square the unit digit, you write it as a double digit. Then multiply all the numbers. 2 times 2 is 4, 4 times 2 is 8. So 484, here is the decimal point. So 0.2 whole square, the value is 4.84. Let's take 4.84. X square, that is equal to 4.84 minus 7, which gives negative 2.16. But we have a power 2, it cannot be a negative. That's why this is also invalid solution. Let's take the last root, which is minus 3.2. Here also, first do square on both sides. Then you will get x raised to the power of 2 plus 7, that is equal to minus 3.2 whole square. Using our square trick, I'm going to find the value of 3.2 whole square, that is 1024, and decimal point is here, that is 10.24. So then x power 2, that is equal to 10.24 minus 7, which gives 3.24. So this is the x power 2 value. Now this is a positive value, that's why we are going to substitute in our original equation. So this is our original equation. So we need to substitute x power 2 as 3.24. If x power 2 is 3.24, if you do again square here, then you will get x raised to the power of 4. So the value is 3.24 whole square, which is 10.49. So let's write here 10.49. The second term, square root of x square plus 7, we consider this as a. Now we are doing the fourth root. So the fourth root is minus 3.2. So now you have to take the second term as minus 3.2. So that's why here 10.49 minus 3.2, that is equal to 7. So when you do subtraction here, 10.49 minus 3.2, which gives 7.29. So the left hand side, the value is 7.29. The right hand side, the value is 7, which is not equal. So that's why the fourth root minus 3.2 is not a valid solution. So we reject this one. So we should take only a as 3. So when you take a as 3, we are getting x as plus or minus root 2. So these are our x values. I hope you like this content. If you like this content, please give your valuable support to me. Thank you for watching.